The first part is just asking you to solve, and when we're solving here, all we're doing is using the square root. First, you want to isolate the x. So you get x squared equals 9. And you guys know that the inverse operation of a square is the square root. So when you take the square root of both sides, I get x equals what? Trissa? 3, but not just 3. Go ahead, Trissa. Yes, plus or minus 3. When you take the square root, you have plus or minus an answer. Why? Why could my x value be 3, but it could also be negative 3? Ryan?
When you square a number, it doesn't matter if it's a positive or negative. It's always going to be positive.
Right. Your answer is always going to end up positive. Very good. When we solve b, we get 3x squared equals 30. X squared equals 10, and when you take the square root of that, 10 doesn't have a perfect square, but you can just leave it in the square root form. X equals plus or minus the square root of 10. Got it, number 1A. Same process. Isolate the squared value. What's your answer for 1A? Andrew?
Plus or minus 3, 5.
Very good. And go ahead and work through the part B on your own, and then you can check your answer with mine. Show of hands, who got x's plus or minus root 2? All right, terrific. So now this is just another thing that you can add to your math toolbox. Whenever you can, whenever you only have an x squared value, you can solve simply by taking the square root. But if I have an x squared value and an x value, it's not quite that simple. That's when you need to factor, or when you could do a process such as completing the square. We did perfect square trinomials a few weeks ago, and perfect square trinomials were whenever we had a value and a c value that were both perfect squares. Well, look at x squared plus 4x plus 4. X squared and 4 are both perfect squares. Now the equals 25, it doesn't really matter at this point. We're just going to hang on to that for a minute, because we're going to focus first on this x squared plus 4x plus 4, and then we'll deal with the 25 in a minute. First, we want to factor the perfect square trinomial. So, factor what's in the red there. Remember, perfect square trinomials, you can use that shortcut of just taking the square root of the a and the c value. Look at the middle sign to know whether it's plus or minus. And in factored form, this would be x plus 2 quantity squared. Now I'm going to set that equal to my 25 because it's asking me to find the solution. How do we undo a square? Steve? Exactly. So when it says find the square roots, what we're going to do is we're going to take the square root of that entire quantity, of the x plus 2. And when we take the square root of a quantity squared, we're just left with that quantity, because the square root and the square undo each other. And when we take the square root of 25, we get plus or minus 5. So now we have two different answers. X plus 2 equals 5, or x plus 2 equals negative 5. And you can solve for both of your x's. So we started with a quadratic, and we still ended up with our two answers. So what's the solution of x squared minus 14x plus 49 equals 25? Again, look at your right side of, or look at the left side of your equation. Recognize that that's a perfect square trinomial. My A and my C values are both perfect squares. The C value is positive. So if I'm factoring just this left side, I have x minus 7 quantity squared equals 25. Once you have that quantity squared, undo the square by taking the square root. So either x minus 7 equals 5 or x minus 7 equals negative 5. X is 12 or x is 2. Number 4, go ahead and work through on your own. You're not going to get nice answers like 12 and 2. You are going to get some square roots and some fractions, but go ahead and try working through number 4 on your own. From here, I'm going to take the square root of both sides. 2x plus 3 equals plus or minus root 3. Now, this is a little bit different because it's root 3. It's not a perfect square. What you do from here, subtract 3 from both sides. So now I have 2x equals negative 3 plus or minus root 3. Root 3 is just a number. It's just like we're saying plus or minus 6. It's just that it doesn't simplify easily, so we leave it as root 3. How would I isolate x? Just by dividing by 2. So now, x equals negative 3 plus root 3 over 2, or x equals negative 3 minus root 3 over 2. And generally, we just leave it in the root form instead of making it a decimal, because if it's a decimal, it's a rounded answer. This is more exact. Now, we were able to do these problems because we had perfect square trinomials. Well, the process of completing the square is what you do when you don't have perfect square trinomials. So here's pretty much just a general explanation of what completing the square is and what it does. It says if x squared plus bx is not part of a perfect square trinomial, you can use your b value to find a c that makes it a perfect square. If we only have x squared and x values, what we can do is we can use the coefficient on x to find a c value that makes it a perfect square. And it's called completing the square because we're coming up with a c that completes the perfect square. Here's a visual picture for you. We've got x squared plus bx. So we have our box. That's where we get x squared from. And then the yellowish box, that is our b value. Now we want to make this into a square. Right now that's a rectangle. So visually, to make this a square, what we would do is we would cut the b value in half and position it on the top and on the side of our x squared. But there's that one little corner piece missing. This square right here is missing. We need to complete the square. So what we would do is we would find what would be the value of that square. Well, as it's showing you, b over 2 and b over 2 are the lengths of both sides of the square. Because from the beginning we took b, we split it in half. That's how we got b over 2, because we split b in half to put it on the top and on the side of our square. So that means that this length right here is b over 2. This length right here is b over 2. And you guys know if you're trying to find the area, you just do length times width. And so we get b over 2 squared as this little green box right here. And that's what the completing the square formula tells you. What you do is you take b over 2, the coefficient on x, divided by 2, and you square it. And you end up with a perfect square trinomial. This looks a little more complicated than it actually is. Let's do one of these problems and you're going to see how simple it is. What would be the value that completes the square for x squared minus 10x? So what we're doing right now is we're trying to make this into a perfect square trinomial. What you do is you take the b value. What's our b value? Coefficient on x. Haley? Right? Take your b value, divide it by 2, and square it. What value completes the square? 25. Because if we had x squared minus 10x plus 25, that would be a perfect square trinomial. A perfect square trinomial that could be written as x minus 5 quantity squared. Completing the square is just the process of finding your c value that allows you to make a perfect square trinomial. Got it, number 4a. What value completes the square for 6x squared, or for 6, geez, I can't talk, for x squared plus 6x? Ryan? Sure.
Why are you just allowed to add 45 to that?
Because we are completing the square. We are transforming this into a new equation in order to solve it. We're going to solve it in the next couple steps, but right now we're just transforming it. Well, right now it's not set equal to anything. That's a good question. But right now, we're not saying that this is equivalent to anything. If we were saying this equaled 6, then if we added 25, we'd have to add 25 to the other side also. But since there's not an equal sign, since this isn't an equation, it's an expression, we're just changing the expression. But you're right, it would change. If you just randomly add 25, yes, it's going to change things. And that's going to take effect whenever we're actually doing the solving, which is the next step. You'll see. In the next step, your question will be answered, I promise. So for number 4a, what value completes the square for x squared plus 6x? You take your b value, divide it by 2, and square it. What value completes the square? Connor? Right. So if I would have x squared plus 6x plus 9, that would be a perfect square trinomial. How could I write that perfect square trinomial in factored form? Tulsi? Very good. What do you guys think? Is it possible for more than one value to complete the square? Do you think I could have a different number other than 9? Ryan? Think about perfect square trinomials. You guess not. And that's going to lead into my next question. Is this number that we find, the constant that we find, is it ever going to be negative? Andy?
No, because you're squaring something.
Exactly. It doesn't matter what sign you start with on B. You're always squaring this value. You're taking the value, dividing by 2, and then squaring it. So there's no way that this value could be negative. So are you going to have more than one value that completes the square? No, there's only one that completes the square. And we also know that it's always going to be positive. Okay, I think we're going to stop there for today, and then we will do the solving part with completing the square tomorrow. So for your homework, what you're going to do is you're going to pretty much start where we started with solving just by taking the square root. And then the second part's going to be having your perfect square trinomial and solving that way. And then the third part of your homework is going to be where you have to find your value to complete the square.